Alright guys, so I wanted to go ahead and make a short video showing you like maybe an equation sheet or a formula sheet you might use on the test. I realize that a lot of people have a lot of they struggle with knowing what formula to use. Once they figure out what formula to use, it's fine, but getting there is the hard part. So I want to make this to help you guys sort of decipher what you might use and when you might use it. So let's see, let's start off with projectile motion. You have the obvious ones, right? XF equals 1/2 AT squared. You have A is equal to delta V over delta T. You have V is equal to delta X over delta T. Let's see what else is there. Oh, yeah, this one right here. VF squared is equal to VI squared plus 2A delta X. That one might be important. And I think that's about it. That's about it that we've used and that we will be using on the test. Okay, let's see. Moving on. Say forces, just on a flat surface. So forces on a flat surface. Well, we know the big one, F equals ma, Newton's second law. We know W equals mg. We know Fn equals W. Let's see, what else is there? Oh yeah, the force of different frictions, so the force of kinetic friction is equal to mu k Fn. Static is less than or equal to mu s Fn. And what else? Oh, you could use this one right here. F net is equal to Fa minus Fk. So the net force, the net force applied on the object is equal to the force that you actually apply. The net force that the object is feeling is equal to the force that you actually apply minus the friction force. And so that works out pretty simply. That's a pretty easy one. And remember that you can always change these into MA, right? And so this really turns into this. MA equals MA minus mu k Fn, really, is what it is. All right, and now let's look at stuff on a hill. All right, objects on a hill. Well, first of all, we know the easy formula, the shortcut formulas for acceleration. A equals g sine theta, so that's when there's no friction. And then here's what it is for friction. G sine theta minus G cosine theta. So friction versus no friction. We deal a lot with acceleration on hills and timing and stuff like that. So you might need this formula right here. XF equals 1/2 AT squared. You might also use A equals delta V over delta T. And also you could use this one, VF equals VI squared plus 2A delta X. So there's a lot of different things. Oh, I forgot, mu K, yeah. So if it has friction, it'll have kinetic friction on this hill. I think that's about all of them that I can think of. If you can think of more, add to your list, but here's my list that I would bring into a test if I were you, and I would say, okay, what type of question am I dealing with? And then using that, I would use, okay, let's look at my different equations I have here for each of those questions. And you can take from each of these different sections, right? You don't have to just use the forces equations to answer forces questions. You can take from projectile or hill, doesn't matter. You just have to know how to use it right. So I would set it up like this. It might be a little bit easier to work with.